Okay, let's look at 10.3, solving equations using the complete the square method, page 539 in your book, right there. Okay, first of all, what we want to look at is an example. Let's say we have the example x squared minus 10x plus 25. Well, the first thing I notice is that that is a perfect square trinomial. Okay? And because that's a perfect square trinomial, there's some things I can do. Okay? So we've got this perfect square trinomial, and let's remember that. Let's do a little memory lane thing here. When I have a perfect square trinomial, I know it's perfect square when I have a squared term at the beginning, a squared term in the third term, and the middle term is 2 times the square root of the first term times the square root of the second term. So let's take a look at it. Square root is x, square root is 5. 2 times 5 is 10, times x is 10x. Is the middle 10x? Yes, it is. It's a perfect square trinomial. So once I have that, because it's a perfect square trinomial, I can immediately go to square root of the first term, the square root of the second term, and I put the sign of the middle term in between them. And that's squared. So that perfect square trinomial immediately factors down to x minus 5 squared. It's still equal to 7. I then take the square root of both sides. Okay, square root of 7 is now equal to the square root of x minus 5 squared. And when I do that, I end up with x minus 5 is equal to plus or minus the square root of 7. When you take a square root, you remember that you can have the plus or minus sign. And then I subtract or add 5 to both sides of my equation, and I end up with x equals 5 plus or minus the square root of 7. Then I'm going to come up over to this side, and I'm going to rewrite that equation as the plus equation and the minus equation. So x equals 5 plus the square root of 7 and x equals 5 minus the square root of 7 to get my two answers. They're approximately 7.6 and 2.4, and there is my answer for that example. Okay, but a lot of times when you have a trinomial, it's not a perfect square trinomial. So what can I do? I can do a thing called completing the square. Let's take a look at that. Okay. First thing I need to notice is what happens when I have a binomial squared. Okay, it always ends up being the first term squared plus 2 times the first term and the second term, so 2 times 6 times x, and plus the third term squared. So if I carry that out, I get x squared plus 12x plus 36. Then you need to notice something, and it's always true in perfect square trinomials, is that if I take half of that middle number, so 12 divided by 2 is half of it, and I square it, it's the same thing as my third number, or the square root of that number squared. So 12 over 2 is 6. 6 squared is 36. These are all equal. Okay? So now that we know that pattern, we can use this pattern and the fact that it's always half to solve some problems. Let's look at example 2 in the book. And we have x squared plus 6x plus c. And they're asking us to find c and make it into a perfect square trinomial. So what value of c do we need to make this into a perfect square trinomial? Well, when we look at this, we know that, let's look at our equation and let's look at our values. Our a is 1, b, small b, is 6, and c is what we're looking for. Well, we know that half of b is equal to 3. And that 3 squared is equal to 9. And 9 is the value that we want to plug into c to make it a perfect square trinomial. And let's check that. I'm going to write that x squared plus 6x plus 9. And remember, For a perfect square trinomial, I have to have the root of the first guy, x, the root of the third guy, 3, and in the middle I need to have 2 times those two values, x and 3. So I've got x, I've got 6x, and I've got x squared, 6x, and I got 9 when I square that. So that is a perfect square trinomial. So notice how we figured what value of c to put in there. And that's really the essence of the completing the square function. Let's look at an example where we need to do that. All right, let's look at example. Well, first let's look at the rules for complete the square rules. The complete the square rules are pretty simple. You must start with something in that form. It can be more than that, but your equation must at least be x squared plus bx. You can have a c value or not, okay? But you have to have that. First thing you do is you find 1/2 of b. Okay, so you find 1/2 of b. You then square that. Square that. And then add the result from number 2 to your original equation. Let's see that in action. Let's say we're asked to solve, and this is example 3 in your book, a squared minus 14a plus 3 equals negative 10. Well, I want to get my equation into this kind of format, so I'm going to get rid of that minus 3. I would look first to see if this is a perfect square trinomial, but since 3 is not a perfect square, this can't be a perfect square trinomial, so I'm going to subtract 3 from both sides. That leaves me with a squared minus 14a is equal to negative 13. And now you can see that I have a squared term and a single term, and I've got that here, a squared and just a. So now I've got it set up to do a complete the square. So what's the first thing I do? Find half of b. Well, b is equal to 14. Okay. Half of b is equal to 7. And 7 squared is equal to 49. So what I'm going to do to complete the square is add whatever term is needed to both sides of my equation that makes the left-hand side a perfect square, and that number is 49. So I'm going to add 49 and 49. I now have a perfect square on this side. That goes to a minus 7 squared is equal to, now 13 and 49, negative 13 and 49 is 36. I then can take the square root. A minus 7 is equal to plus or minus square root of 36. A minus 7 is equal to plus or minus 6. Add 7 to both sides. A is equal to 7 plus or minus 6. A is equal to 7 plus 6. A is equal to 7 minus 6. A is equal to 13. And A is equal to 1. And so my solution set is 1, 13.